In this example, we're going to find the consumer and producer surplus. Suppose that the supply and demand functions are S of Q equals Q squared over 2 plus 200, and demand D of Q equals 275 minus Q squared over 4. Find the following: the equilibrium point, the consumer surplus, and the producer surplus. So the equilibrium point is that point Q0, P0. And to find this, we're going to think of our supply and demand as a system of equations, and we're going to set supply at Q equal to demand at Q. Set the two functions equal to each other and get Q squared over 2 plus 200 equals 275 minus Q squared over 4. And since we have fractions in this equation, one way that we can clear out the fractions is by multiplying the whole equation by the least common multiple of the denominators, which is 4. So if we multiply this whole equation by 4, we get 2Q squared plus 800 equals 1,100 minus Q squared. You don't have to do that step. It just makes the numbers a little bit nicer. And then we want to solve for Q. Add Q squared to both sides, we get 3Q squared plus 800 equals 1,100. Subtract 800. We get 3Q squared equals 300. Divide by 3, Q squared equals 100. And we get that our Q value, square root of 100, is 10. So Q equals 10. This is our Q naught value. So now to get our P naught value, we can plug into either equation, either S of Q or D of Q. So P naught will be S evaluated at Q naught, so S of 10, which would be 10 squared, 100, over 2 plus 200. 100 over 2 is 50, plus 200 is 250. So our equilibrium point is 10, 250. So quantity 10, price $250. And we will need to use that for both the consumer and the producer surplus. So recall that consumer surplus from the overview video is equal to integral from 0 to Q naught of the demand function minus P naught dq. So plugging in our values now, our Q naught is 10. So we get integral from 0 to 10. Our D of Q function is 275 minus Q squared over 4. And then our P naught value is 250. So minus 250 dq. And simplifying this integral 0 to 10 of 275 minus 250 is 25 minus Q squared over 4 dq. And then we'll integrate. Integral of 25, the constant, is 25Q, minus, we're going to do the reverse power rule, so add 1 to the power to get 3, divide by the new power of 3. And then we also have that 4 in the denominator, evaluating this from 10 to 0. And then I'm going to go ahead and simplify this denominator. 3 times 4, we're going to write 12. So our consumer surplus is going to be 25 times 10 minus 10 cubed over 12 minus 0 plugged in would just be 0. So our consumer surplus is going to be approximately, because we will need to round, $166.67. Okay, now the producer surplus. Recall from the overview video that this is integral 0 to Q naught of P naught minus the supply function S of Q dq. So then plugging in our known values, Q naught is 10, P naught is 250, and then we plug in S of Q for our supply function. So minus the supply function would be minus Q squared over 2 and minus 200, because we subtract both parts of that supply function. Simplifying this, we get integral 0 to 10, 250 minus 200 is 50, minus Q squared over 2 dq. Integral 0 to 10, actually let's evaluate the integral. Integral of 50 would be 50q since it's a constant, and then for q squared, add 1 to the power, q to the third, divide by the new power of 3, and then we have that 2 in the denominator. Evaluating this from 0 to 10. And I'm going to simplify that 3 times 2 in the denominator to 6. So plugging in our q values, we get 50 times 10 minus 10 to the third over 6. And when we plug in 0, we just get 0 for both pieces. We're going to get that our producer surplus is approximately, because again we need to round, $333.33.